Hello, this is Abhishek Gade, and yes, we can see that there is a planetary gear. Okay, there is a planetary gear, and now that is pinned here at point O, and we can see this OC link is there. Okay, so yeah, this link is rotating clockwise. You can see the direction. Okay, it is clockwise. It will be like this, clockwise. Okay, and what another thing is given? Yeah, this is the rack on which it is moving. We can say that it is an outer rack. Okay, so that outer rack is again moving counterclockwise. See the direction. Okay, the things which are given is the distance from this C to O. Okay, and from this C to the rack. Okay, the outer rack. Okay, so this distance we know. I haven't mentioned here so that we do not get confused. We can see the clear figure what is happening. And now the question is they are asking us to find the angular velocity of this gear A. See this. Okay. So what can we do here? Okay, let us think something. So we should always think from the scratch what to do. Okay, I can see something is rotating, the angular velocities are given. I think there is some concept like relative velocity. Yes, there is something like that. Let's see. Okay, so okay, see if this is going counterclockwise and this is moving clockwise, where would be the direction of velocity at point O? The linear velocity, where it would be directed. Obviously, this will go like this. This will go like this. Okay, this will go like this. So the velocity will be perpendicular to this OC link. See here, I have shown it VO. But then the rack is moving in this direction. So at this point, at the touching point, where would be the velocity directed? See here, VP. Okay, the VP is directed in this direction. Okay, in the direction of angular velocity as shown. Okay, of the rack. Two things done. We have shown the directions of two velocities. Okay, and see this VO is perpendicular to this OC link. Okay, that is clear. Now what to do? Yeah, we know that V is equal to R omega. We know that. So something to be done with that also. Let's see. Okay, so we know this R, right? We also know omega. Okay, we know the angular velocity. We know the link, that is the length of this link R. What can we do? Simply, we can find VO, that is omega R. Got it? See, the question is we want to find the angular velocity of A. Okay, want to find the angular velocity of A. Now, for point P, okay, let's see what we can do. So, VP is directed towards this side. Okay, see the velocity. And VP is omega of this rack multiplied by the radius of radius. How to calculate? From the center of curvature. It is this. So this total, this complete would be RCP, and we know this. I told you already in the beginning of the lecture. Okay, so we can calculate VP also. Two things of the same circle, the same gear we have found. We found VO, we found VP. Take care of the directions. Right side positive, left side negative. Also angular velocity also you need to take care of the directions. Okay, if omega is clockwise, then what will you do? Positive. If counterclockwise, then what will you do? Negative. Okay, so yeah, so but yeah, VO is in left, is towards the left direction, so I think it should be negative. So whatever is given, okay, 3, is it getting coming 3, 30, 40? It would be minus 30, minus 40. Remember, do not forget these conventions or everything is wrong. And this VP is directed towards the right direction, so it would be positive. Nothing to change here. Okay, so VO, VP we know. VO relative to P. Okay, O relative to P. Okay, now are you getting it? This is relative velocity concept, right? Okay, so let's do this. Okay, so what would be VO with respect to P? That would be omega A, right? The angular velocity of this gear, what we need to find, multiplied by radius of this OP. This is also known. The radius of OP is also known. Okay, so three velocities we know the equations VO, VP, and VO relative to P. Done. Okay, so what would be the direction of O relative to P? O going this side and P going this side. Seems that O relative to P would be directed towards left side, because this is going to move towards left and this is going to right. Okay, so O relative to P will move towards left. Okay, and when I said left, that means what would be the direction? That would be negative direction. Okay, negative. So this would be negative omega A RO P, and we want to find omega A, that is the angular velocity of this planetary gear. Okay, so we have VO, VP, and VO relative to P. So just apply the relative velocity concept. See this, VO equal to VP plus VO relative to P, right? So done. Just substitute all these things, and the unknown only thing which is left is omega A, and hence we will get the omega A, that is the angular velocity of this gear. Okay, the planetary gear. Thank you.